Okay, this is my solution for the problem that we did on Monday of week 8. And this problem has a little bit of everything. This is a conservation of momentum and energy problem. In 2 dimensions. So that means we're going to have 3 equations. Momentum, remember, is a vector, and energy, fortunately, is a scalar. Okay, so the problem looks like this. You have a 2m and an m, and they're traveling with some velocity v. And after, what you know is that the smaller ball goes directly to the right, meaning the velocity in the y direction is 0. And the other ball goes in some direction we don't even know. And so let's check. The things that we don't know are v1x, and we don't know v2x or v2y. 3 equations, 3 unknowns. Okay, so believe it or not, this is enough information. Here we go. So we're going to write down that the sum of the momentum in the x direction, the sum of the momentum in the y direction, and the sum of the kinetic energies are conserved. And we'll solve those 3 equations simultaneously. So here we go. Let's choose x and y in the normal way. And so we get 2mv, that's the initial in the x. In the y, we just have mv. And the kinetic energy, well, they both have kinetic energy, and kinetic energy is a scalar. So 1/2 2m v squared plus 1/2 m v squared. Now let's set these equal to what they are afterwards. So afterwards, we have a, let's see. So in the x direction, we have m v1x plus 2m v2x. In the y direction, well, v1 has nothing, so it's 2m v2y. Okay. Now what about the kinetic energy afterwards? Well, 1/2 m v1x squared is the velocity of that ball squared, plus 1/2 2m 2m times v2x squared plus v2y squared. And that's the v2 squared afterwards. Okay, notice I don't separate that kinetic energy into 2 parts. It just has a speed squared. Okay, so then I'm going to do the usual thing here. I'm going to divide through by m, and I'm going to divide through by the 1/2 to make this a little bit simpler. And so here we go. I'll just rewrite it here. And I get, let's see. Okay, so I get 2v is v1x plus 2v2x. And then I get v is equal to 2v2y. Okay, and then 2v squared plus v squared is equal to v1x squared plus 2 v2x squared plus 2v2y squared. Okay. It actually makes more sense to combine these together, so I'll make this a 3. Here we go. Okay. Well, I can tell I'm going to have a quadratic, which is kind of a bummer, but, well, I can deal with that. So I have 3 unknowns, and I'm going to eliminate 2 of the unknowns, and so I'm going to choose v1x to solve for first. And so that means that I'm going to take the top equation and say that v2x is equal to v minus 1/2 v1x. And this equation says that v2y is equal to 1/2 v. And then I'm going to take both of these and plug them into the third equation. And so it's going to look like this. It's going to be, and I better start on the next page. So I have 3v squared equals Now, I have v1x, that thing I'm trying to solve for, squared, plus 2 times v2x, and v2x is v minus half v1x squared. Let's see. Yeah, plus 2 times v2y squared, which is 1/2 v. Okay, so I just plugged in for these two values, and now I can solve for what I need. So I'm going to do that, and so I get v1x squared plus 2v squared minus half plus a half is 1 v1x plus 1/4 v1x squared. And they're both actually multiplied by 2, so I'll just stick this in here. No, maybe that'd be confusing. So I'll do this. 1/4 v squared. Okay, so I squared those things. Let's see. So I'll multiply through by the 2's. v1x squared plus 2v squared minus 2v v1x plus a half v1x squared plus a half v squared. And so I'll combine this term and that term, and I'll get 3/2 v1x squared. I'll combine this one and this one. Let's see, 4/2, 5/2 v squared. Okay, minus 2v v1x. Okay. Oh, and I have a 3v squared over here. So these halves are kind of creeping me out. So I'm going to multiply both sides by 2. 6v squared is 3v1x squared plus 5v squared minus 4v v1x. Can I combine anything else? Ah, yes I can. I have a 6 and a 5, and so I will move everything to one side, and I will get that 0 is 3 v1x squared plus, no, minus v squared minus 4 v1x. So maybe this doesn't really look like a quadratic to you, but notice that I'm trying to solve for the v1x, and I'm allowed to know what the v's are. And so that means that actually I'm going to rewrite this. I'm going to divide through by v squared, and I get 3 v1x as a fraction of v squared minus 4 v1x as a fraction of v minus 1. Okay, so I'm going to solve the quadratic. So I'm going to pause and look this up on the internet because I'm lazy, so hold on. Okay, I'm back, and what I found is that v1x over v is 1.55, or it's a negative number. But I know that's not true because, well, I mean, the problem said it goes in the forward direction, so it must be the 1.55. So in other words, v1x is equal to 1.55v. Okay, there's my first solution. And of course, the next ones are going to come pretty fast. v2x is equal to where did I write that down? v2x is v minus a half of v1x, and v2y is equal to just half of v. Oh, well, actually, I already solved for this, didn't I? So this is 0.5v. That's pretty simple. Okay, so the only one I have to do here is this one, and so I'm going to say, so let's see, half of that is 5, 15, what is that? No, can't do it in my head. Hold on. Okay, so I get, let's see, I get 1 minus, and half of that is 0.775 times v, And so if I want to take that equation and subtract off the 1, I get 0.23. So the question asked, by the way, you should check. You should check to make sure that energy is conserved. That's how you know you did it right. And of course it should be, because we solved all three equations simultaneously, but you should check. Anyway, the problem asked for the speeds of each ball. So ball 1 has a speed of 1.55 times the original velocity, and ball number 2 has a speed of the square root of 0.23 squared plus 0.5 squared times velocity, or 0.55 v. And those are the answers. Fun problem.